A-star search algorithm navigating intelligent paths. A concise visual introduction. A-star combines path cost and heuristic estimates to find optimal routes efficiently. Understanding graph construction. Nodes, edges, and heuristics. We model problems as graphs. Nodes represent states, edges represent action with non-negative weights. A-star uses three values per node. Gn exact cost from start to n, Hn heuristic estimate from n to goal, Fn Gn plus Hn priority for exploration. Heuristic guide search. Good heuristic reduce explored nodes while preserving optimality when admissible. Custom graph. Nodes, weights and heuristics. Here is the custom graph we'll use for the walkthrough. Nodes S start A, B, C, D, H, G. Edges have positive weights. Heuristic values estimate remaining cost to G. Edge weights, example, S to A2, S to B4, A to C2, B to C1, C to D2, D to G3, B to G8, A to G9. Introducing A-star, the core principles. Best first search, A-star prioritizes nodes by lowest Fn equals to Gn plus Hn, balancing known cost and estimated remaining cost. Optimality. When an admissible heuristic never overestimates, A-star is guaranteed to return an optimal path. Efficiency. A-star explores fewer nodes than uninformed searches when the heuristic is informative. The algorithm in action step by step. We run A-star on custom graph. Key list, open and closed. At each step, pick open node with lowest F, expand neighbors, update G, H, F, and move node to closed when expanded. Example, initial values. G of S 0, H of S 7, F of S 7, expand S, add A, G equals to 2, H is equals to 8, F is equals to 8. And B, G is equals to 4, H is equals to 4, F is equals to 8. Visualizing A-star walkthrough of the search process. Graph animation frames, illustrate node selection, cost updates, and final path reconstruction. Final optimal path is as follows. S, A, C, D, G with the total cost of 9. The major power of heuristics are admissibility and consistency. Admissible, H of n is lesser than or equal to true cost to goal for all n. Ensures A-star returns an optimal path. Consistent, monotone. H of n is lesser than or equal to C of n, C of n dash plus H of n dash for every edge. Guarantees F value never decrease along a path and simplifies implementation. Good heuristic is an admissible heuristic. Bad heuristic is an overestimating heuristic. Consistency implies admissibility. If heuristic is consistent, nodes need not to be reopened when found with a better cost. Why A-star is optimal? Proof sketch. High-level reasoning. If H is admissible, F of n never overestimates the true optimal cost through n. A-star expand nodes in non-decreasing F order. Therefore, the first time the goal is popped from open, its G equals the true optimal cost. Consistency strengthens this by keeping F values monotonic, preventing re-expansions. The real-world applications of A-star are robotics and motion planning, route finding and navigation, gaming AI. Other uses are planning and logistics, puzzle solving, motion planning and drones, and AI search problems. Key takeaways and next steps. Use informative, admissible heuristics. Prefer consistency when possible. Balance optimality and performance. Explore further. Implement A-star on the provided graph. Experiment with different heuristics and profile node expansion.